If you look at any machine, you'll notice there are bigger parts all working together in groups and smaller parts working together within those groups. The body is exactly the same, and it's fascinating to look at the subsystems behind the scenes. There are two overarching categories of the muscle systems: local and global. Local muscles stabilize the spine and peripheral joints. Deep muscles of the spine, like the transverse abdominis, is an example of a local muscle that stabilizes the spine, whereas the rotator cuff muscles provide a joint support system for the shoulder. The global muscular system is made up of larger muscles that initiate movements and tend to function across one or more joints. It's also commonly called the movement system, since it takes on more of the heavy lifting, quite literally, with everyday functional movements like walking, pushing, pulling, and squatting. Now, bear with me, folks, because we're almost at the main attraction here. The global muscular system's main function is to transfer forces through the core to create the most efficient movement possible, while also providing additional support to protect the trunk and spine as the body moves. To break it down even one step further to really illustrate how muscles of the movement system work together, the global muscles can be categorized into, drumroll please, subsystems. The subsystems include the deep longitudinal, posterior oblique, anterior oblique, and lateral. These muscular subsystems highlight how multiple muscles work together to create movement. Remember, muscles rarely work in isolation. Instead, they contract and relax in synchrony with other muscles. Without these subsystems, normal movement would be impaired, and injury risk and reduced performance would increase. Each of the subsystems is mirrored on the left and right sides of the body. Now let's go deeper into the deep longitudinal system and explore how it functions. The deep longitudinal subsystem includes muscles of the lower leg, hamstrings, and lower back region. Working together, these muscles absorb and control ground reaction forces during walking and running. For example, with each step, ground reaction forces are transmitted from the lower leg, through the hamstrings, and into the lower back. As such, these muscles must be able to properly work together in order for us to walk or run with efficiency. Next in the spotlight is the posterior oblique subsystem. The posterior oblique subsystem is made up of the latissimus dorsi, the thoracolumbar fascia, which is connective tissue of the low back, and the contralateral, or opposite, gluteus maximus. The latissimus dorsi and contralateral gluteus maximus create a nearly straight line with each other across the sacroiliac joint, which is a small joint in the pelvis. When the muscles of the posterior oblique subsystem contract, they produce a pulling force across the thoracolumbar fascia and a stabilization force at the sacroiliac joint. In other words, the latissimus dorsi and the gluteus maximus work together to help support the pelvis and the sacroiliac joint. When it's mirrored for both the left and right sides of the body, the posterior oblique subsystem forms an X across the low back and provides extra support for the pelvis. The posterior oblique system works together with the deep longitudinal system, particularly during gait. For example, when you're walking or running during heel strike, forces are traveled from the lower leg, through the hamstrings, to the gluteus maximus, and across to the contralateral latissimus dorsi. As a result, these muscles must collectively work together in harmony to produce efficient movement. If they don't, movement can be altered or injury may occur. Next, we'll get into the anterior oblique subsystem. The anterior oblique subsystem is similar to the posterior oblique subsystem, but on the front side of the body. The muscles include the obliques, the inner thigh muscles, and the hip external rotators. The obliques and opposite adductors are the most common visualization of this subsystem because of the X pattern made across the front of the body. The anterior oblique subsystem creates stability from the trunk through the pelvis to the hips, and also contributes to rotational movement. The anterior oblique subsystem and posterior oblique subsystem work together as a global force couple in enabling rotational force production in the transverse plane. Simply put, these two subsystems help us rotate our torso. The lateral subsystem is made up of the lateral hip, medial thigh muscles, and the opposite quadratus lumborum, all of which provide stability and movement in the frontal plane. Together, these muscles create and maintain frontal plane, or side-to-side, stabilization of the core during movement. You'll see this during movement like walking, running, and lunges. The lateral subsystem also provides stability of the lower extremities to prevent abnormal or unwanted frontal plane movement patterns, like unwanted hip and thigh adduction during a squat. In other words, these muscles work together to help stabilize the hip while standing on one leg, and helps prevent the knees from caving inward during squat-type motions. Let's wrap this up by talking about how the subsystems work together. Now, even though we looked at each individually, the really cool thing about subsystems is how they work together in coordinated and complex ways when we move. They work synergistically to perform efficient movements and stabilize the spine and pelvis. Remember, too, that movement relies on the nervous and skeletal systems as well. So issues with joint function or failure of the nervous system to supply the appropriate signal can lead to improper movement patterns, even if all the muscles in a subsystem have proper length-tension relationships. The human body really is a machine. There are so many moving parts, all working independently and together. The more you study it, the more complex it becomes, and the more we can truly appreciate its design.